It's important to pay attention to the costs to use transitions. Transitions connect different network elements together, like an existing pipe to a new trench, or a manhole to a trench. By default, they have a cost of $12.19 per foot. But you will want to change that. Let's look at an example. We have an existing pipe, a new trench, and then a transition connecting the two. This transition is 3 feet long, at a price of $12.19 per foot. The cost to use this transition is $36.57. This means the cost to move from the new trench and break into the existing conduit is $36.57. In the rules dialog, this cost is under existing pipe to trench transition. If this does not reflect the cost for you to break into an existing conduit, you might want to change that. How would you do this? Well, we have two factors that need to be accounted for. The cost to trench from the new trench to the existing pipe, and the cost to break into the pipe. The transition represents both. That cost to trench from the new trench to the existing pipe should probably be the same as the standard trench cost, and it should be a variable cost. After all, part of what a transition represents is the physical route dug from one network element, the possible trench, to another, the pipe, and that should be captured. However, there are more costs here than just that. This transition allows you to enter an existing pipe. There is the cost to trench to the pipe, which we have already covered, but also the cost to carefully excavate and cut into it. This needs to be included in the cost to use this transition. It should probably be a fixed cost. After all, it's only applied once. Let's look at another example. Exactly the same as before, but now there's a manhole on the existing pipe. We're going to trench and break into the existing manhole instead of the pipe itself. Great! So we've got the cost to trench, the transition to the manhole, and then the cost to use the pipe, right? Not so fast. We actually have a second transition here, the transition from the manhole to the existing pipe. Remember, transitions connect different network elements. To move from one network element to another, you need a transition. A trench is a network element. A manhole is a network element, and the pipe is a network element. We need transitions to move between them all. Depending on the quality of your data, this extra transition distance may be large, it may be small, it might even be 0, but it has to be there and will be charged. So how does this work out? Well, we've got the cost of the trench, the cost of the transition to the structure, the cost to use the manhole. We'll talk more about equipment costs in another video. The cost of the transition from the manhole to the pipe, and then the cost to use the pipe. Let's deal with the transition from the trench to the manhole first. Just as before, this also represents ground which is trenched, so there should be a variable cost here representing that. There should probably be a fixed cost as well, representing the cost to break into the manhole. Alright, how about the other transition, from the manhole to the pipe? Well, that will depend on how your data is structured. In this example, the manhole object is right on top of the pipe object. The pipe is already connected to the manhole in all likelihood. There isn't work here that needs to be done to fit the two together. Maybe this transition should be free. Here you can see an existing pipe, and then a new manhole. This transition type will be trenched to existing pipe, despite the fact it appears to be sourced in the manhole. It represents a break into an existing pipe, just as it did in a previous example. This should definitely not be free. There are no universal right answers here. What you choose for a transition cost will depend on the nature of your workspace. Think of what they represent and how they occur in your network and design, and try to use them to capture costs.